Hello, in this video I want to talk about the speed difference between compiled code and interpreted code. Historically there have been two ways to run computer programs. One is through interpretation or interpreting. You have a source file. That source file is translated into a model by an interpreter, and that interpreter executes the model. That is something like the old BASIC language or Python or Unix shell scripts. Those are interpreted languages. Interpreted languages are very portable because you can run that source code anywhere where there is an interpreter. You can take a Python file and run that anywhere on any machine that has a Python interpreter. Now, the other way of doing this is compiled code. You take some source code, you run it through a compiler, and the compiler turns it into the native instruction set for the processor on that machine. Compiled code is very fast, but it is not portable, and that's the trade-off. So we have a trade-off between portability and speed. Interpreted languages like Python and BASIC are very portable, but they don't have the speed that the compiled languages do. Compiled languages, on the other hand, are very fast, but they're not portable. And I wanted to show you the speed difference between compiled code and interpreted code using a very old computer, which is the Radio Shack Color Computer 2 from the early 1980s. Because if you run an example on a really old machine like this, the speed difference really shows up. It becomes very noticeable. So the first thing I'm going to do is load the interpreted version of this little test program that I've written. So let me load my program here. Load, and I think it was called colors.bas. So I'm going to load a source file here called colors.bas. BAS is the extension for a BASIC program. There's the source code for the program. This is written in a language called BASIC, which all of us learned in the 1980s in middle school. It was the first language many people learned. And it is an interpreted language. This machine has a ROM chip with a BASIC interpreter in it. So the program is being run by the interpreter, which is a program being run by the CPU, right? So there's a layer of overhead there, and that's why interpreted code is slow, because the CPU has to run the interpreter. Now let's run this and see how fast it is. And you can see, well, okay, you know, without some baseline, you might say that's really fast, but I don't think it is. It's kind of like, well, if this were a game and I'm trying to redraw the screen, well, that's kind of horrendously slow. So it's just kind of sitting there crawling along, trying to color in the screen with colored squares. That's all that thing does. Now let's load a version of that that's compiled. This version of the program was written in assembly and compiled down into the processor's native instruction set. So I have to use a different set of commands to load it. And that's going to be load m test2.bin. So load m means load a machine language program. So this program is written in the processor's native language. And now if I run it, now to run it I use a different command. I don't say run, I type exec. That means execute a machine language program. Now compare this difference in speed between this program and the previous program. Boom, done. Okay, so that was fairly an astonishing difference in speed right there. So on a machine like this, compiled code is about 300 times faster than interpreted code. So that's the advantage of compiled code. It's much faster than interpreted code. So C or C++, which are compiled, are much faster than Python, which is interpreted. Now, what does C# use? C# actually uses both approaches. It uses a hybrid approach. So you have a compiler called the C# compiler that takes your source code and compiles it down into an intermediate format, a bytecode, kind of a pseudo assembly language for a hypothetical platform. And then when you run your program, that bytecode, that optimized semi-compiled version is then run by the .NET runtime environment. And that .NET runtime environment then is interpreting an optimized version of your program, and that gives you a very good blend of speed and portability. You get almost the speed of compiled code, but you get some portability as well. So there are versions of the .NET runtime like Mono that can run on Mac and Linux. So so the .NET framework does, or C# does have a good blend of speed and portability, and that's because it uses that virtual machine approach that Java uses. Your code is interpreted down to a byte code, which is then run by an interpreter, which is the .NET runtime environment, right? So it's that virtual machine approach, and that seems to be the way to go, because you get that good blend of speed and portability. You get the best of both worlds. So I hope that was good. This little demo here was good at illustrating the speed difference between compiled code and interpreted code, and kind of lets you know how the C# and the .NET framework work.